Okay, Bismillahirrahmanirrahim. We'll continue doing these problems from the old exams. That was the last one we did. Related to this section 7.3, where I solve system of differential equation and eigenvalues are either real distinct or non-real eigenvalues. Okay. Now I have this question. He gave me lambdas. This is lambda 1, 8. This is lambda 2, 5. This is lambda 3, 0, where I have a0t. Okay. Now we're finding the eigenvectors. For lambda 1 equal 8, what I will have? I will have 6, that's minus 2, minus 4, 6, 1, 6 minus 8, that's minus 2, 1, 1 minus 2, 1, times k1, k2, k3. One trick which you can do, I know that this eigenvector where I have k1 equal 1, k2 equal 1, k3 equal a should satisfy the equation. So I substitute in any equation, I should get k3. So I substitute, for example, what are the equations? Now let me do the equations. Minus 4k2 plus 6k3 equals 0. I have k1 minus 2k2 plus k3 equals 0. I have k1 minus 2k2. Yeah, without solving anything, plug it, for example, in this equation. I have k1 1 minus 2 plus a equals 0. Very clear, a equal 1. And this is satisfy this equation for sure. It's the same. Satisfy this equation. A equal 1. A, which is k3. A is k3. So I have minus 2 minus 4 minus 6 plus 1 plus 6 equal 1. So without solving anything, without solving the equation. Since I have two values, the third one I can get. And the same thing for the other ones. Now for lambda 2 equal 5, what I will have? 1 minus 4, 6, 1, 6 minus 5, 1, 1, 1, 1, 1, 1, times k1, k2, k3. So what are the equations? Let me write them here. K1 minus 4, k2, plus 6, k3 equals 0. K1 plus k2 plus k3 equals 0. K1 plus k2 plus k3 equals 0. Without solving anything, I know k1 is b, k2 minus 1, k3 equal minus 1. Plug it here. What I have? B minus 1 equals 0. So very clear, b equal 2. Very clear, b equal 2. Check here is the same. Here I have 2 plus 4 minus 6 equals 0. Correct. So I get b equal 2 without solving anything. Without solving the system. Now for the last one, lambda 3 equal 0. What I have 6 minus 4, 6, 1, 6, 1, 1, 6, 1 times k2, k3, k4, k1, k2, k3. That would be 0, 0, 0. So what are the equations? 6k1. If I did not solve anything, huh? So I have this is k1 plus 6k2 plus k3. The third equation is the same, very clear. So I have k1, 1, k2c, k3 minus 1. Like it's in the last one, I'm getting what? 1 plus 6c minus 1 equals 0. Very clear, c equals 0. Like this there, we have 6, 0, minus 6, 0. So it's correct. So c equals 0 without solving anything. So you have a plus b plus c, 1 plus 2 plus 0, which is 3. Or you can solve the equations in each case. That will be also correct. Now I have 2 by 2 matrix. This is, I can write it 1, 2 plus I, 2, 0. So this is B1 and this is B2. Very clear. And this is alpha plus I beta. So alpha 0 and beta 4. Okay, what you want? You want the general solution. What will be x1? That will be b1. Alpha is 4. I don't have beta is 4 and alpha is 0. Cosine 40 minus, what will be the other one? 20 sine 40. X2 will be the other way. 20 cosine 40 plus 12 sine 40. So it will be x C1 x2 x1 plus C2 x2. That will be C1 cosine 40 minus 2 sine 40. That will be 2 cosine 40 plus C2 times what? 2 cosine 40 plus sine 40, and they have 2 sine 40, which is this one, will be my correct answer. If the general solution is given by this, I think we did that before. Yeah, I need to do it again. I remember I did it before. Sometimes they repeat the questions. Okay. Yeah, which is this one, and the answer is minus 21. Exactly is this one. But you wrote here the first order homogeneous system. The other one he said, I think the system or the homogeneous system or something like that. Yeah, the system, which is the same, exactly the same. Okay, this one. Yeah. Yeah, I need first to find diagonal values. Actually, you don't need to do that. Why? Because I have here minus 2 and 5, minus 2 and 5, 5 and minus 2, 5 and minus 2, 5 and minus. So very clear it's minus 2 and 5. But to be sure, let me do it. This will be 6. So I have lambda square. Lambda minus 4 lambda, that will be minus 3 lambda. Minus 4 minus 6. So it's lambda square minus 3 lambda minus 10. So you have lambda minus 5 lambda plus 2, which what I'm expecting, lambda 1 minus 2 and lambda equal 5. Now for lambda 1 equal minus 2, what I will have? For minus 2, that will be 6, 1, 6. Minus 1 minus 2, that will be 1. K1, K2. So I have same equation, 6K1 plus K2 equals 0. In other words, K2 is minus K1. So let K1 equal 1, K2 equal minus 6. So I have my V1 will be 1 minus 6. Yeah, and X1, 1 minus 6, E minus 2T. Now for lambda 2 equal 5, what you will have? Minus 1, 1, 6, minus 1, minus 5, minus 6, times K1, K2 equal 0, 0. Very clear, I have K1 equal K2. So V1, 1, X2 will be 1, 1, E5T. What is the general solution? C1, X1 plus C2 plus C2, which is this, very clear. A 2 by 2 real matrix has an eigenvector. He gave me the eigenvector, and the eigenvalue is 2i, the positive one. This is what I'm looking for. So this is 2 minus 1 plus 2, 0 times i. B1, B2. Now if you want the general solution, what will be x1? Let me write it here. That will be 2 minus 1 cosine 2t minus 2, 0 sine 2t. And x2 will be what? Will be 2, 0 cosine 2t plus 2 minus 1 sine 2t. Yeah, so it is x1 2 cosine 2t minus 2 sine 2t, and the other one is minus cosine 2t. And x2 is 2 cosine 2t plus 2 sine 2t, and this is minus sine 2t. What is x? C1 x1 plus C2 x2, which is directly at this one. Yeah, easy one. 4 minus 5, 5 minus 4. Yeah, it's a little bit complicated. Let me try to do it carefully. 4 minus lambda minus 5, 5 minus 4 minus lambda. That will be what? Lambda square. 4 lambda minus 4 lambda gun. Minus 16 plus 25. So lambda plus or minus 3i. Good. That would be lambda. So solve for the eigenvector. I have what? 4 minus 3i. I'm using lambda equal 3i, the positive one. Minus 5 minus 4 minus 3i times k1, k2. Yeah, for sure these two equations are the same. You can check it. Yeah, so I have k1 is 4 plus 3i over 5 k2. So let k2 equal 5. K1 will be 4 plus 3i. So V1 would be what? 4 plus 3i, 5. And that is 4, 5, 3, 0, I. Okay. Now let's be careful with x1, x2. x1 will be 4, 5 cosine 3t minus 3, 0 sine 3t. x2 will be 3, 0 cosine 3t. Okay. Plus 4, 5 sine 3t. Okay. I have x will be c1 x1 plus c2 x2. So I have x add 0. Yeah, be careful. It will be c1 times what? Cosine 0 is 1, sine 0 is 0. So I have 4, 5 plus c2, 3, 0. That equal 0, 3. So I have 4c1 plus 3c2 equal 0. And 5c1, what is this? Equal 3. Yeah. So from here, c1 equals 3 over 5. Plug it here. That means 12 over 5 equal minus 3c2. So c2 equals what? Minus 4 over 5. Okay, so my x, c, what is c1? 3 over 5, x1 minus 4 over 5, x2. And that equal what? Multiply 3 over 5 by x1 minus 4 over 5 by x2. Let me do it. 3 over 5, that will be 12 over 5 cosine 3t minus 9 over 5 sine 3t. Okay, multiply here by minus 4 over 5. That'll give me minus 12 over 5 cosine 3t minus 16 over 5 sine 3t. Yeah. In the denominator, I think it will be easier. That will be 3 cosine 3t. This is 0 gone. Minus 4 sine 3t. No, look at this. This is cancelled. Minus 25 over 5, which is minus 5 sine 3t And here I have 3 cosine 3t minus 4 sine 3t. So I have this answer. Okay, now let me do questions from the book. Apply the eigenvalue method for the section. Find the general solution of the given system. If initial values are given, find also the corresponding particular solution. Use the computer system. Blah, blah, blah. Okay. Now I solve the system. I have what? I let capital X to be x1, x2. Actually, I'm doing this for all of these problems. I will not repeat it to save time. So I have x prime 1, 2, 2, 1 times x. Find eigenvalues. That will be lambda square minus lambda minus 2 lambda plus 1 minus 4. That will be lambda square minus 2 lambda minus 3, which is lambda minus 3. So I have lambda 1 minus 1 and lambda 2 equals 3. Oh, answer yes. Now I solve for lambda 1 equal minus 1, but I have 1 minus 1, 2, 2, 2, 2 times k1, k2 equal 0, 0. So I have k1 equal minus k2. So I have v2, v1 will be equal minus 1, 1. Okay. Now I will do for lambda 2 equal 3. What I have? 1 minus 3, that will minus 2, 2. 2 minus 2, 1 minus 3, which is minus 2, times k1, k2 equals 0, 0. Here I have 2k1 plus 2k2 equals 0, which means k1 equal minus 2. Here I have minus 2k1 plus 2k2 equals 0, which means k1 equal k2. So my v2, 1, 1. Yeah. So to have x1 will be 1 minus 1 e minus t, and x2, 1, 1 e 3t. My general solution, c1 x1 plus c2 x2. That gives me c1, 1 minus 1 plus c2, 1, 1. By the way, this is the first row. C1 is minus t plus C2 is 3t. This one minus C1 is minus t plus C2 is 3t. That will be x1 of t, x2 of t. That's x1 and that is x2. Yeah. Next one. Question number 3, which is on the suggested problems. What is new? I have initial condition in this case. Okay, let x equal cx1, x2. So I have x prime 3, 4, 3, 2. Eigenvalues 3 minus lambda 4, 3, 2 minus lambda. That will be lambda square. Yeah, minus 2 lambda minus 3 lambda minus 5 lambda plus 6 minus 12. I have how to get minus 5. Yeah, I have lambda minus 6, lambda plus 1. Yeah, so I have minus 1 and 6. Yes, correct. So I have lambda 1 equal minus 1, lambda 2 equal 6. Now for lambda 1 minus 1, it will have 3 minus minus 1, that will be 4, 4, 3, 2 minus minus 1, that will be 3, times k1, k2 equals 0, 0. Plus k2, let k2 equal minus 1, so k1 equal 1. So you have v1 will be 1 minus 1, which means x1 e is minus t. Now for lambda 2 equals 6, what I have, 3 minus 6, that will be minus 3, 4, 3, 2 minus 6, that's minus 4, times K1, K2 equals 0, 0. So I have actually one equation, which is the same if multiplied by minus 1. So I have K1 4 over 3 K2. Let K2 equal 3. I have K1 is 4. So V1 will be what? 4 and 3. And X2 will be 4, 3, e to the power 60. What's my original solution? C1 X1 plus C2 X2. Now he gave you this initial condition, which means X at 0 will be 1, 1. To find the C's, so I have X at 0. Yeah, that will be C1. X1 at 0, I have 1 minus 1 plus C2 4, 3. That should equal 1, 1. So I have the equations C1 plus 4C2 equal 1 minus C1 plus C32 equals 1. Add them. You have what? Yeah. You have, this is cancelled. You have 7C2 equal 2. So C2 equal 2 over 7. Plug it here. So you have C1 plus 8 over 7 equal 1. So C1 minus 1 over 7. Yeah, 7 over 7 minus 8 over 7. That will be minus 1 over 7. So X will be minus 1 over 7. X1 plus 2 over 7. X2, take 1 over 7 common factor. I have what? Minus 1 times X1. What is X1? Minus 1 times this. So it will be minus 1, 1. E minus T. Okay. Okay. This is 2 times, so we have plus 8, 1 over 7, minus E is minus T, plus 8, E 6T, and E minus T, plus 6, E 6T. In other words, I have X1, small x1, that will be 1 over 7. X2 functions is 1 over 7. E minus T plus 6 E60. Yeah. Yes, correct. Next one, also have condition. Yeah, these are suggested problems. Now let's try to do more. Now I have x prime 2 minus 5, 4 minus 2 times x. What I have? That will be 2 minus lambda minus 5, 4 minus 2 minus lambda. That will be lambda square. 2 lambda minus 2 lambda gone. Minus 4 plus 20 is equal lambda square plus 16. So lambda equal plus or minus 4i. So I have no real solution. No problem. The solution condition. Yeah. Okay, with 80. Okay. Yeah, now for lambda equal 4i, what I have? 2 minus 4i minus 5, 4 minus 2 minus I minus 4i times k1, k2 equals 0, 0. I have a 2 minus 4i k1 minus 5 k2 and 4 k1. For sure, these two equations are the same. How to be sure? Yeah. If you want to lie, yeah. Multiply this. This is multiplied by 2 minus 4i over 4. You should get 2 minus 4i. So multiply, this is the same, by the same value. 2 minus 4i. 8i minus 8i gone. You have minus 4. This is 16i squared, which is minus 16. Minus 20 over 4 minus 5. So these two equations are the same. Okay. Just as double check. So I have what? 4k1 equal 2 plus 4i k2. In other words, k1 is 1 plus 2i over 2k2. I did k2 equal 2. So k1 will be 1 plus 2i. So v1 will be 1 plus 2i and 2, which is 1, 2 plus 2, 0 i. v1, v2. Okay, so this is x1. Yeah, 1, 2 cosine 40 minus 2, 0 sine 40. Okay, x2. Now I reverse it to 0 cosine 40 plus 1, 2 sine 40. What is my solution? C1 x1 plus C2 x2. Now I have what? X at 0, it's 2, 3. So now x at 0, yeah, just I need the cosine. The sine 0 is 0. So no worries. So I have C1, 1, 2 plus C2, 2, 0, which is C1 plus 2C2 and 2C1. And that should equal 2, 3. Okay. Yeah. Is it correct? 1, 2, 2, 0. Yeah. 1 plus 2i over 2. Yeah. 1, 2. This is 2, 0. This is 2, 0, 1, 2. So you have C1, 1, 2. This is 2, 0. If you invest it, it's better, but it's okay. So I have C1 plus 2C2 and 2C1 equals 3. So from here, I'm getting C1 equals 3 over 2. Plug it here. So you have 3 over 2 plus 2C2 equal 2. So you have 2C2. That will be half. So C2 equal 1 over 4. So my solution will be X. What is C1? 3 over 2 x1 plus 1 over 4. Yeah, C2 is 1 over 4, x2. And that will be what? Multiply 3 over 2 by x1. So I have 3 over 2 cosine 40 minus 3 sine 40. Okay. Multiply this by 1 over 4 plus half cosine 40 plus 1 over 4 sine 40. Yeah, in the denominator, I have 3 cosine 40. This is 0. This is 0. 2 times 1 over 4 plus half sine 40. Yeah. It will be 2 cosine 40. Yeah, that we simplify it. I have 3 over 2 plus half. That will 4 over 2, which is 2 cosine 40. This is 12 over 4 minus 11 over 4 sine 40. And this is 3 cosine 40 plus half sine 40. Yeah. Okay, let me do this one. X prime 1 minus 2, 2, 1, x. And they have here x at 0, 0, 4. By the way, I solved this before. 1 minus 2, 2, 1. Yeah, just to save time. I think I solved the equation. But maybe not the same. Yeah, not the same eigen, not the same initial condition. We'll do it many times. This is x1, this is x2. So let us save time. Copy that. X1 will be 0, 1 cosine 2t. Instead of doing the calculation again, we have x1 will be 0, 1 cosine 2t. Okay. What is that? Minus 1, 0 sine 2t, 80. The rest it will be okay. One zero t. Very clear. X2 should be the other way. 1, 0 cosine 2t plus 0, 1 sine 2t. So, and x will be C1 x1 plus C2 x2. Now the initial condition, x at 0 will be C1 0, 1. E to the power 0 is 1, cosine 0 is 1, sine 0 is 0. Ignore it. Plus C2 1, 0 equals 0, 4. Yeah, so I have actually have C1, C2 is C1 times 0 plus C2 times 1, and this is C1 equals 0, 4. So C2 equals 0 and C1 equals 4. So my solution will be 4x1. I need only x1. That times 4, that give me what? Minus 4 sine 2t and 4 cosine 2t. Yeah. Times 80. Don't forget the 80. So implies on the small x1 is minus 4 sine 2t 80, and small x2 4 cosine 2t 80. This is times. Okay. Yeah. Usually write it the other way. 80 cosine 2t. No problem. Both are correct. Just to make sure this is the argument of cosine. This is not part of the argument of cosine. Okay. I have x1, x prime, I mean. Same thing, I will let x equal x. Okay. That will be minus 50, 20, what these numbers? Minus 60 times x. Okay. So what will happen? I have a minus lambda I. That will be what? Minus 50 minus lambda 20, 100 minus 60 minus lambda. Yeah, lambda square. 60 lambda plus 50 lambda plus 110 lambda. 50 times 60. This is what? 3000. minus 2000. Yeah, that will be lambda square plus 110 plus 1000. Yeah. And that I can make it what? Lambda minus 10 lambda minus 100. Plus, sorry, plus. I want it to be plus, and this is plus, equal 0. So lambda 1 equal minus 10, and lambda 2 equal minus 100. Good. Second degree, it will be easy to deal with. Lambda 1 minus 10. So you have what? Minus 50 plus 10, that will be minus 40, 20 is 100. Minus 10 minus 10 minus 50. K1, K2 equals 0, 0. That give me minus 40 K1 plus 20 K2 and 100 K1 minus 50 K2. Yeah, this implies K1 equals half K2. Yeah, take it and divide by 40. Yeah, 20 over 40 equal half, and the same thing here. And here the same thing, K1 equal half K2. Same equation, K2 equal 2. That implies K1 equal 1. So V1 will be 1, 2, and X1, 1, 2, e to the power minus 10t. Okay. Now, what will be for lambda 2 minus 100? What will happen? I have minus 50 minus, and that will be 50, 20, 100. Minus 60 plus 100, that will be 40 times K1, K2 equals 0, 0. Very clear, multiply by 2, you get this. So I have only one equation. Let me, just to save time, plus 40 K2. So I have K1 is minus 2 over 5 K2. Minus, cancel 0 with 0, minus 4 over 10, which is minus 2 over 5. So I need K2 to be 5, K minus 5, K1 it will be 2. So V2 would be 2 minus 5, and X2, 2 minus 5, e to the power minus 100t. So it is my X, C1, X1, plus C2, X2. That would be C1. What is that? 1, 2, e minus 10t, plus C2, 2 minus 5, e minus 100t, which I can rewrite it C1, 2C2. And X2 will be 2C1 minus 5C2. Yeah, that would be X1, X2. The function, the solution. Okay, done. Yeah, this one, I have what? X prime, 6 minus 4, 6. 1, 6, 1, 1, 6, 1. We did that before. Let me just show you that we did it before. Yeah, 6 minus 4, 6, 1, 6, 1, 1. Actually, he said this is question 18. So I know the answers. You can write the answer. So done before, done before. Okay. This one, what will happen? X prime, 3, 6 minus 6. 1 minus 2, 4, 1, 1, 1 times x. So this is my air. Okay. Yeah, solve the system. That will be what? 3 minus lambda, 6 minus 6, 1 minus 2 minus lambda, 4, 1, 1, 1 minus lambda. Okay. Do the eigenvalues. You get what? Yeah. I can multiply the second row by -1 and add to the third row to have zeros. I think that will help. -1 and add, that will be 0. -1 and add, it will be lambda plus 3. -1 and add, that will be -3 minus lambda. Okay, that will be what? 3 minus lambda times what? Cancel this with this. -2 minus lambda 4. Lambda plus 3 minus 3 minus lambda. Okay. -1. Cancel second row and first column. 6 minus 6. Lambda plus 3 minus 3 minus lambda. Yeah, what I have? 3 minus lambda. Be careful now. We have what here? Lambda square plus 3 lambda plus 2 lambda plus 5 lambda plus 6 minus 4 lambda minus 12. I'll come back to this. -1 times what? -18 minus 6 lambda minus 6 lambda minus 18 plus 18. That will be, sorry, that will be plus 6 lambda plus 18. Yeah. Am I right? Yeah, -18 minus 6 lambda. This is minus, so 6 lambda plus 18. Cancelled. Everything cancelled here. That's good. So I have 3 minus lambda times what? This is lambda square plus lambda minus 6. And that will be 3 minus lambda plus 3 times lambda minus 2. Am I right? -6, 3 minus 2, 1. Good. Equals 0. So I have lambda 1 minus 3. Lambda 2 is 2. Lambda 3 is 3. Good. Finish this. Now for lambda 1 equal -3. What will happen? Yeah. I have what? Lambda 1 equal -3. What I have? 3 minus, that will be 6. 6 minus 6. 1 minus 2 plus 3. That is 1, 4. 1, 1, 4. Yeah. So I have what? 6k1 plus 6k2 minus 6k3 equals 0. And I have k1 plus k2 plus 4k3 equals 0. Can divide 6, first one. So you have k1 plus k2 minus k3 equals 0. You have k1 plus k2 plus 4k3 equals 0. Subtract these two, you get what? Minus 5k3 equals 0. So k3 should be 0. Plug it in any of these equations. So I'm getting what? This is 0. This is 0. These two equations are the same. So I have k1 equal minus k2. So I let k2 to be -1. K1 will be 1. So the answer V1 will be 1 minus 1, 0. That will be V1. Yeah. 1 minus 1, 0. No. With -3, I have 3 minus -3. That will be 6. 6 minus 1. 6, 6 minus 1. None of them. Where is that? minus 3, 6, 6 minus 1. This is 1 minus 2 plus 3. That will be 1, 4. This is 1, 1, 1 minus minus, and that will be 4. So very clear. K1 equal minus K2. Yeah, one is minus, one is plus. Is it 0 minus 1, 0? No, it cannot be. Okay, so V1 equal this. So my X1 will be 1 minus 1, 0, E minus 3T. Yeah, I think, well, it is correct. Unless I did a mistake somewhere. No. Okay, now for lambda 2 equals what? What is my lambda 2? 2. You try to do them in arranged. 3 minus 1, that will be 1, 6 minus 6. 1 minus 2 minus 2. That will be minus 4. 4. 1. 1. 1 minus 2, that will be minus 1. Times K1, K2, K3 equals 0, 0, 0. Yeah. Since this one is 1, I think we can do it by Gauss elimination. Let me do Gauss elimination. What they have? 1, 6 minus 6. Multiply by minus 1 and add, that will be 0. By minus 1 and add, minus 10. By minus 1 and add, that will be 10. By minus 1 and that will be 0. By minus 1 and add, that will be minus 5. By minus 1 and add, that will be 5. 0, 0, 0. Now divide by minus 10. 1 minus 1, 0, 0. Now multiply by 5 and add. That will be 0. That will be 0. So I have K2 equal K3. Yeah. And if K2 equal K3, plug them here. So I have K1 plus 6 K2 minus 6 K3 equals 0. If these are the same, so they're cancelled. So K1 equals 0. So I let K3 equal 1. I'm getting K2 equal 1. So V2 will be what? 0, 1, 1. And X2 will be 0, 1, 1, e to the power 2t. Yeah. Now for lambda 3, which is 3, what we have? We have 0, 6 minus 6. So K2 equal K3. 1 minus 5, 4. Okay. 1, 1, 1. 1, 1 minus 2. What I have, the first one, I have 6K2 minus 6K3 equals 0. So K2 equal K3. That will make my life easier. And I have K1 minus 5, K2 plus 4, K3 equals 0. So K1 will be 5, K2 minus 4, K3. They are the same, so I have K3. Check. If they are the same, yeah, the last one will be correct. So my V3 will be 1, 1, 1. I let K3 equal 1. So X3 will be 1, 1, 1, A3T. So my solution X will be C1, X1 plus C2, X2 plus C3, X3. Just list it, you will get the answer. Yeah. This one, I think we did before. 5, 5, 2, minus 6, minus 6, minus 5, 6, 6, 5. Yeah, we did it before. let me check 552. I think I did it as a system of equations, not as matrix form. Yeah, actually I did it at the beginning. Yeah, this is the question. I did it in detail, so I think you can follow it. Yeah. Okay, no need to do it again. I have now the last one, which I think it will be not difficult, but complicated than before. Yeah, the last one. I have x prime 3, 0, 1, 9, minus 1, 2, minus 9, 4, minus 1 times x. Source. Yeah. And I have the initial condition x at 0 will be 0, 0, 17. Yeah, I'll try to do as much as I can. A minus lambda I, 3 minus lambda 0, 1, 9 minus 1, 2, minus 9, 4 minus 1. This is a suggested problem because of that I'm solving it. So do the expansion with the first row. 3 minus lambda cancel. Oh, this is minus lambda. Minus lambda. Okay. Yeah, let me be careful. Do it in details. It's plus 0, then it's plus 1. Cancel the first row and the third column. You have 9. Okay. So you have 3 minus lambda. What is this? Yeah. Lambda square. Lambda plus 2 lambda. Okay. Plus 1 minus 8. Plus, this is what? 36. This is 4. Yeah, this is 4. 36. Plus, minus 9. Minus 9 lambda. Minus minus, huh? So we have minus times minus times minus. Everything is minus. Okay. That will be 3 minus lambda. I have lambda square plus 2 lambda minus 7. Yeah, here I have what? This is 27, so I can take 9 common factor. I have 3 minus lambda 2. Good. That will make my life easier. 3 minus lambda. I have lambda square minus 2 lambda minus 7 plus 9, which is plus 2. Yeah. So I have lambda equals 3. And I have this lambda will be 2 plus or minus together, 4 square, 4 minus 8 over 2. That will be 1 plus or minus I. Good. That will be, this is minus, this is plus 2 lambda. Why I change it to minus? Sorry. That will be minus 2, and that will be minus 1. Okay. Now for lambda, 1 equals 3. That should be easier. I have what? 0, 0, 1, 9, minus 4, 2, 9, minus 9, 4, minus 1, minus 3, minus 4, K1, K2, K3. Here, I have K3 equals 0. These two are the same, and I have 9 K1 minus 4 K2 equals 0. So I have what? K1 equal 4 over 9 K2. So let K2 equal 9. K1 will be 4. So V1 will be what? 490. And X1 will be 490 e to the power 3t. Good. Yeah. Same answer. Yeah, the next one will be complicated. Now for lambda equal -1 plus I. To solve the system, 3 minus lambda. It will be 4 minus I, 0, 1. 4 minus I, 0, 1. 9. What is the other one? -1 minus -1. That will be 1. So I have minus I. Good. And 2. I have -9, 4. The last thing is -1 minus. That will be minus I again. Times K1, K2, K3. How to solve this system? So I have actually 4 minus I K1 plus K3 equals 0. Okay. From the first one, I can get to know K3 is 4 plus I K1. Yeah, this is from the first one. Plug it in the second and the third. I should get the same. 9K1, 9K1 minus IK2 plus 8K1, correct? Plus 2I K1 equals 0, which means what? Do you have 17? No. Okay. So I have 17K1. Did I did a mistake? This is 9 4 2 minus I. I have -1 a minus 1 minus -1, that will be 1, that's minus I, correct? This is 4 minus I. 3 minus -1 minus I, 4 minus I, 0, 1. Okay, so everything is okay. I have this, so K3 will be, sorry, here is the mistake. I feel the numbers are becoming bigger, which is, this is 4 minus I, take it to the other side, you have what? I minus 4 times K1. Okay, so I have 4 minus I, no, apply it in the second one, so I have 9K1 minus IK2 plus 2K3 plus 2IK1, okay, minus 8K1, okay, equals 0. So what we have 1 plus 2IK1 minus IK2 equals 0. Now plug in the second equation. I have minus 9K1. I'll show these two equations should be the same. Plus 4K2 plus 4K2 minus IK3 minus I times I, that will be plus K1 minus I times 4 plus 4I K1 equals 0. So what we have? 8 or 4 minus 8 plus 4I K1 plus 4K2 equals 0. Okay. Multiply the first one. Is it minus 8 plus 4I K1? Yeah. I'm blessing K3 with K1. Okay. So equations are K1, K2. K1 and K2, yes. Multiply, this is, no. Multiply this by I over 4 by minus I over 4, you get this. So multiply this by minus I over 4, you get 2I plus 1, the first. So these two equations are the same. So from here, I'm getting what? K2 will be equal to, take it the other side, be careful, 8 minus 4I over 4 K1. So I let, no, which is what? No need to do that. 2 minus I K1. So if I let K1 equal 1, what I will get? K2, 2 minus I, and K3, what is it? Minus 4 plus I. So my V2, V2, yeah, will be 1, 2 minus I, minus 4 plus I. Yes. And that, I can split it. 1, 2 minus 4 plus I, 0 minus 1, 1. So my solutions, yeah, x2 will be what? Yeah, this is B1. This is B2. Yeah, that will be, yeah, a little bit complicated. 1, 2 minus 4. What is alpha? This is alpha, this is beta. Alpha equal minus 1, and beta equal 1. So that will be cosine t plus 0 minus 1, 1 sine t times e to the power minus t. This is x2. x3 will be what? Oh, this is minus, sorry. This is minus the formula. Now we reverse it, and that will be plus. Plus, this is just a formula. Sine t is minus t. That will be x3. Yeah. This will be the solution. What will be my x? C1, the general solution. Until now, did not do the initial condition. Wow, it's a nightmare. 2 plus C3 x3. Yeah. You want to write it as a complete solution. What is x1? 490. That will be C1 490 E3T plus C2 with this one, which is what? Cosine T. That's it. Here I have 2 cosine T plus sine T. Here I have minus 4 cosine T minus sine T. All of this times EUS minus T plus C3. Yeah. I don't think you'll see something like that in the exam. Sine T. This is minus cosine T plus 2 sine T cosine T minus 4 sine T times EUS minus T. Yeah. Okay. 2C2 minus C3. Yeah. I think everything is okay. Now I need to plug the initial condition. Yeah. I will not. Let me see. X at 0. If it is complicated, I will leave it. 0, 0, 17. And what is X at 0? That will be C1 490 plus C2. Just I need the cosine part. Cosine will be 0. That will be 1, 2 minus 4. 1, 2 minus 4 plus C3. That will be 0 minus 1, 1. 0 minus 1, 1. Yeah, I need to solve this equation. So I have 4C1 plus C2 equals 0, 9C1 plus 2C2 minus C3 equals 0. They have minus 4C2 plus C3 equals 17. It is too complicated to solve. Yeah, I think I will leave it for you to do. To find C1, C2, C3. Yeah, let's find C1, C2, C3. I want to finish it. Then plug it. Then plug it there to find. Then substitute n x equals C1 x1 plus C2 x2 plus C3 x3 to find the solution. I think I will leave it. I need to solve this system, which will take some time. I will leave it for you to do. That will be the end of this section 7.3. I did it because it suggested problems. I think now it's very clear. You can finish it. Let me stop the recording. Now I finished 7.3. Then I will do 7.6. Stop the recording. Thank you.